Start the
recording.
Perfect.
Okay. All right. Can everybody hear me properly?
Yes.
Okay, perfect. And all right. So thank you very much for having the opportunity to present a very interesting project we right now do with Deutsche Bahn, and I'm also very glad to say that it's actually a collaboration between Deutsche Bahn and DLR. So DLR is actually helping us in this project in terms of SUMO knowledge and extending the functionalities of SUMO for trains. Okay. So what I want to do is I want to give you some insights in like actually a project we're doing, and it's a project together with DB Regio. So more particular, it's actually a project with the S-Bahn Stuttgart. So as in the talk earlier, it's about the Stuttgart area. The difference now is that it's about the S-Bahn. So the trains, the local trains in Stuttgart. So what's the goal of this project? Actually, the goal of this project is developing and evaluating a so-called reinforcement learning algorithm. And why do we do this? We do this to suggest data-based decisions for railway dispatching. Maybe like in small words, railway dispatching means that if deviations from the timetable occur, then the dispatchers have to do some certain decisions, such as they have to cancel maybe a train, or they have to reorder the order in which trains are arriving at a specific station. So what are the more qualitative goals? It's actually the prediction of like quantitatively the consequences of that, so predicting the consequences of the dispatching decisions in the context of delays or for trains, but also for passengers. Of course, what we want to do in the end is we want to generate decisions that actually lead to optimal reduction of delays. So that's the overall goal. And why are we doing this? Also, of course, to reduce delays, but a second goal is also to be able to actually steer higher capacities on the rail network, because of course the traffic demand is increasing, and we need to have tools to also steer higher capacities. And in the end, of course, it's also something positive for the customer, because having this database decisions allows also for optimizing the customer information as they become more as the process becomes more automated and more transparent. So that is kind of the setting we are in, and always think of that we are in the area of Stuttgart. And so what do? We actually, in this project, we built two main components in order to solve this problem. And this is first component would be, we call a digital twin. You can also say just a simulation of the operations of the S-Bahn in Stuttgart. So what we do is we have first of all, of course, that we have the infrastructure of Stuttgart, and of course some tools for analyzing the traffic flow. And I will go a little bit more detail into this, but this is the one thing. So we have the simulation and the digital representation of our infrastructure and of our trains. And the second one, big thing we are developing is a reinforcement learning training environment, where we can actually train and evaluate certain models and train and evaluate the models with respect to the digital twin or the simulation we built in the first place. And that is the integration of these two is, of course, also something we want to achieve. And now I want to give you a little bit more detail about, of course, and for the digital twin. And that is also like the main focus of the collaboration between DLR and Deutsche Bahn, as we use SUMO as the main simulation tool. And for the reinforcement learning training environment, we use the Python library rlib. Okay, but I will go a little bit into detail later. Okay, how do we actually create the simulation? You can actually think of this as a simple workflow. It's simple workflow, but of course it was quite some work to actually do this. But the main idea is that we have all the data at Deutsche Bahn. So we have it all. So we have data about our infrastructure, we have data about our timetables, and of course we have also data about delays and how actually arrival dates and departure dates. And what we kind of did is we did use all this data and we transferred it into SUMO language. So for example, the infrastructure data, it's actually quite nice because it's also decoded into XML files. And it has, of course, a different structure than the net files in SUMO, but you can actually transfer them into each other. And maybe like to give you a little bit of overview how this will look like, I have prepared this video where you can see how this this is actually generated. Here you can see actually, first of all, on the left upper corner, you see the Stuttgart net, where all the trains are actually just going. And then you can also see into detail that we actually modeled so that the data we used actually models every single track, every single signal, and every single bus stop. It looks a little bit like, say, not completely smooth, but this is a little bit, this is the reason for that is that it's the data format we use, that it does not have like actual mapping data, but more or less it's a graph data where you have like not complete, which we transferred into not something completely smooth, but this is just optical things. But in the end, this is what we did to have our digital twin. And in order to, as you have seen, it's not completely, let's say, the overview is not completely great. So what we did actually is we transferred this simulation into a web front end. So what we did is we used the simulation data and transferred this simulation itself into a web front end where you have like a little bit more overview about the things and a little bit more, let's say, a schematic simulation. And I can also show you how this looks like. Actually, we did this we implemented this with React and SVG, which are the main packages. And here you can see, you can actually now, this is the simulation from SUMO, where you can actually like control the simulation here with this slider. You can zoom in, zoom out. You get the most important train numbers, you get the delays, and so the dispatcher can actually see the last simulation of the situation in Stuttgart and play a little bit around with this. This is has actually been developed together with dispatchers in Stuttgart to their so that it meets their requirements. Okay, this is a little bit about the simulation, and maybe what about the reinforcement learning part? So maybe just give you a little bit. I don't have a lot of time, but just give you a little bit about terms of reinforcement learning. So what is the reinforcement learning cycle consists of? It consists first of all of an environment. You can see here. You can mainly think of this as our simulation. And then you have to represent each state of your simulation in terms of an array. This is the representation of the state of the environment. And then you have an agent which actually can manipulate let's say the simulation, which in our term would be the virtual dispatcher, as you can say. So the agent can do some actions, and then what happens is then you can say, is this action good or bad? You can actually give a reward to each action made. And this is how the system learns itself to optimize the actions in such a way that the reward is maximized. And just to give you a little bit brief overview of how we modeled the whole thing is actually, so what we wanted to do is mainly two things. We want to see the optimal order change of trains. So in which order do trains actually arrive at the stations? And this is we actually modeled with signals. So this is a very schematic way of modeling it, but you have two signals, and actually the reinforcement learning algorithm controls these two signals. And there's also another thing what a dispatcher can do. That would be another agent, a rerouting agent. So a lot of times what you see is if there's a lot of traffic, if there's like a traffic jam, then actually the train is going back earlier. So it doesn't go all the way, it returns, like it changes the route and changes the direction earlier. And this can be done, be modeled by rerouting the trains at a specific place. That are the two agents we actually modeled. Then also you have to think a little bit about how you let's say how you model the state. And what we actually do is, you have seen it a little bit. What we did is we have this simulation in Stuttgart, and we made a grid world. So we transferred all of this into a grid world where you can have colors representing trains, delays, and stuff like that, so that we actually get this into the like a matrix, and let's say a tensor, which can be used for the system. And maybe the last thing which we modeled is the delay difference. So we looked at you have a specific state as 0, you do some action, and then you ask the system, is the delay reduced or is it increased? And this is the reward you actually we looked at. And just to have a little bit of a feeling, I will show you a trained model on a specific situation. Namely, here you can see it's a traffic jam which goes from this direction, and then the question is, what is the order the trains are going and this specific point? Who's gonna come first? The trains on the left or the trains who comes from the south? And yeah, just to give you a little bit of overview here, you can see actually the reinforcement learning deciding at each step which order you actually take. And on the right hand side, you can see the difference of delay over time with the reinforcement learning algorithm and with the time schedule, like the tracking algorithm, which would just take the same order as the time schedule would suggest. And yeah, what you can see is actually that it's just a little bit of glimpse of a result, but you actually can do some improvements when you compare it to the schedule. And the reinforcement learner every time decides newly which train to actually let further. Okay, and as I also now running out of time, that was actually everything I wanted to share to you. Just a small glimpse into the project. It's a lot of details, of course, but time was not. I was trying to give you some facets of it, and I'm open to. I hope there will be still some room for questions. I'm not sure, because now it's 10, but I'm